Okay, so let's look at tubuloglomerular control. Okay, so what happens? We're looking at what happens at the glomerulus when this is sort of ongoing. So, the afferent arteriole can handle brief changes in blood pressure and that kind of thing. But what happens if it's a little more chronic, a little more got the blood pressure up? The vasoconstriction can't last forever, right? So there's a different apparatus involved in maintaining that GFR. And it involves the juxtaglomerular apparatus. Okay, so of course we have to draw our Bowman's capsule, okay, and our glomerulus. So we have our glomerulus in here, coming out, going this way, here, and there. So our afferent arteriole, efferent arteriole. Same thing. Here's Bowman's capsule, glomerulus. Okay. So the juxtaglomerular apparatus has to do with, it involves the distal convoluted tubule. So the distal convoluted tubule comes up here. Okay. And there are cells that are associated with the distal convoluted tubule, if you remember. Okay. And these cells were the macula densa cells. There were also cells associated with the vessels. So there were little cells here. And these cells were called juxtaglomerular cells. I think they're also called granular cells, but we'll call them juxtaglomerular cells. Okay, and again, we know this is the distal convoluted tubule. So what do macula densa cells do? Well, they monitor the filtrate. If you remember, we said that. Okay, so macula densa cells they monitor the filtrate. Okay, they monitor the filtrate for sodium. Okay, so if they perceive the condition of the filtrate to indicate low blood pressure, that means GFR is low. So that means basically sodium will be low, blood pressure will be low, and that causes the macula densa cell to do something. Okay, it's monitoring the filtrate, it's monitoring for sodium. Not a lot of sodium means that blood pressure's down. Okay, So when the macula densa cells find or feel low blood pressure, what they do is macula densa cells signal the juxtaglomerular cells, the juxtaglomerular cells, to secrete renin. And we've sort of looked at this before with the heart chapter and with blood pressure and that kind of thing. But this is where it comes from. Okay, so the juxtaglomerular cells, part of the vessels, cause the secretion of renin into the blood. So what renin does, renin signals a plasma protein. So a plasma protein is a protein that's in the blood. And this protein is called angiotensinogen. And this protein is always there, but it's not active. It's angiotensinogen. It's not active yet. It's just floating around waiting for a signal. Okay? So renin signals angiotensinogen to become angiotensin 1. Okay. Once angiotensin 1 is there now, if there is an enzyme called ACE, then angiotensin 1 can become angiotensin 2. So angiotensin 1, when it contacts the ACE enzyme, then it becomes angiotensin 2. Okay, so now we have angiotensin 2. So what does angiotensin 2 do? So angiotensin, the effects of angiotensin 2 are these. Angiotensin 2 causes vasoconstriction. So is that vasoconstriction just at the afferent arteriole? No, it causes vasoconstriction all over the body. We're trying to lower blood pressure. Okay? So causes vasoconstriction. Increases thirst. And it increases cardiac output. Sorry, it's trying to increase blood pressure. Sorry. So it causes vasoconstriction. That means the vessels are getting smaller. That means the pressure on the walls is getting higher. It's increasing thirst. So you're drinking in more. You're bringing in more fluid into the vessels. That's causing more pressure on the walls, increasing blood pressure, and increasing cardiac output, which is bringing more blood circulating in the system, increasing the pressure on the walls, causing increased blood pressure. So angiotensin 2 causes all those things body-wide, not just what's going on at the afferent arteriole. Okay. So when blood pressure is low, this apparatus that's monitoring the filtrate going through the distal convoluted tubule, filtrate running through there, that will sense that blood pressure is low because there's low sodium. Okay, that will do all these things by stimulating renin to come from the juxtaglomerular cells. And then renin, of course, will cause the activation of angiotensin II. Okay, so if sodium is high, what happens? Well, nothing here. It doesn't stimulate the juxtaglomerular cells to secrete renin because renin will increase blood pressure. If sodium is high, that means blood pressure is also high. So it will not cause that process of secreting renin into the system. All right. Okay, so the next part is the start of reabsorption. So remember, at the renal corpuscle, we are only talking about filtration at the renal corpuscle. From here on is where reabsorption begins. Okay, so there's no reabsorption going on in Bowman's capsule. It is just filtration, just stuff being filtered out of the blood into the capsule. And then as we get into the tubules, starting with the proximal convoluted tubule, so the PCT here, that's where reabsorption starts.